Okay, let's jump into some examples. Example 1, we're using segment addition. So we know that to make up AB, we can take segment AN, which is this segment here, plus segment NB over here, and that'll add up to the whole segment AB. And we know this because of the segment addition postulate. Okay, so over here on the left side, we're going to solve the problem. On the right side, we're going to explain why we can do that. Okay, well, we know that AN is 2x minus 6, and we know that NB is x plus 7. And that's because we can substitute in the things we know. All we did was substitute in these two pieces. Okay, then we're going to simplify. We can combine like terms. We've got 2x plus 1x is 3x, and negative 6 plus 7 would be 1. We simplified. Okay, now we want to get 3x by itself, so we subtract the 1 over. 25 minus 1 is 24. We subtracted 1 from each side to get rid of it. Then if you divide by 3, 24 divided by 3 is 8. And we divided by 3 on each side of the equal sign. Okay, we know x is 8. We're trying to figure out what AN is. So 2x minus 6, we know that that's what AN is, but we're going to put in 8 for x. So 2 times 8 is 16, minus 6 is 10. So AN is 10. We're substituting in 8 for x. Then we're going to substitute in 8 and B also. So we had x plus 7, now we have 8 plus 7, and we know that that's 15. So we know AN is 10, we know NB is 15, which checks because the sum of the segment lengths equals 25. We knew that AB was 25 when we started. 10 plus 15 is 25. We're good to go. All right, let's look at number 2, finding lengths. Okay, so we know that M is the midpoint of RT. So we know that from R to M has to be the same as from M to T. And that's because of the definition of midpoint. Okay, well, we also know RM is 5x plus 9, and MT is 8x minus 36. All right, and we just substituted in our two pieces. Then we want to move these around so that we can get x on one side and a number on the other. So if we add 36 to both sides, this one will cancel out over here. 9 plus 36 gives us 45. We added 36 to each side. Then we want to get the x's together, so we're going to subtract 5x. 8 minus 5x is 3. We subtracted 5x from each side. And then we're going to divide 45 by 3, and we get 15, because if we divide by 3, we get 15. Okay. Now we know what x is, and we can substitute that in. So we're going to put 15 in for x. So 5 times 15 plus 9 gives us 84. We're going to substitute 15 in again. 8 times 15 minus 36 gives us 84. We substituted 15 for x. Okay, then we're trying to find RT, so that's the whole thing. So it should be 84 plus 84, because we take those two pieces. If we add those together, we get 168 because of the segment addition. We took two pieces and added them together. Segment addition postulate. RM and MT are each 84 units, which is half of 168, the length of RT. And we know that that's right because we said that M was the midpoint, so that means each piece has to be the same in length. Okay. Number 3, naming angles. Name the angle at the right in 4 ways. Okay, so the name can be the number between the sides of the angle. So we've got this angle here. So we could say it's angle 3 if we were using the number. The name can be the vertex of each angle. The vertex means that's where the 2 rays meet. So that'd be G. We could say angle G. Let's fix that a little bit. Angle G. Finally, the name can be a point on one side of the vertex and a point on the other. So I could say it's CGA would be one choice. Or I could go the other way and say it's angle AGC. So naming angles is pretty simple. If there was another line in here, I wouldn't want to use angle G because I wouldn't be sure exactly if we're talking about this angle or the one over here. So you got to be careful when there's an extra line in there. All right, last example. Using the angle addition postulate. Suppose that the measure of angle 1 is 42 degrees. So we know that this angle here is 42. And suppose that the measure of angle ABC, so that's this whole angle here, is 88. We're trying to find the measure of angle 2. Well, we know that measure of angle 1 plus 2 has to be the whole thing because of the angle addition postulate. Because angle 1 plus angle 2 gives us this whole big angle. We know that angle 1 is 42, and we know that the whole thing adds up to 88 degrees. We just substituted 42 for 1 and 88 for ABC. Then if I do 88 minus 42, I get 46, and we subtracted 42 from each side. So we know that the measure of angle 2 is 46 degrees. If we wanted to check, we could do 42 plus 46, because that should add up to 88. So 2 plus 6 is 8, 4 plus 4 is 8, we're good to go, we got it. Okay, now you are going to do the check for understanding. Okay, in this first one, it says EG is 100, find the value of X, then find EF plus and FG. Okay, so the whole thing is 100. That means when you add both of these pieces together, that's equal to 100. So you're going to figure out X first and then figure out each piece. Okay, number 2, Z is the midpoint of XY. Okay, so draw yourself a line. We've got XY. We know Z is the midpoint. And we know that this whole thing is 27. We need to find XZ, so that's this part over here. If we know Z is the midpoint, how are you going to find what that segment is? Okay. 3, name angle CED 2 other ways. So angle CED, be careful about how you're naming it. You need 2 different ways. Part B, would it be correct to name any of the angles angle E? Think about what we talked about there. All right, and last, number 4, if the measure of angle DEG is 145, so that's this angle here, find the measure of angle GEF. So you're trying to find the other side. Well, if you notice, DEF makes a straight line, so that's got to be a straight angle. And that should help you in finding the measure of angle GEF. Okay, go ahead, get those problems done. If you have questions, make sure you're asking me, and we should be good to go.